Hi all, today's topic is theoretical distribution. What are all the topics to be covered in the full unit? It's nothing but theoretical distribution. It's continuation of your first unit. It's a random variable. Random variables are divided into two types, discrete random variable and continuous random variable. We have so many distribution, but according to our syllabus, only two distribution in a discrete, binomial distribution and Poisson distribution. Same in the continuous random variable, we have so many distribution. So according to our syllabus, it is only exponential distribution or normal distribution. So we have to study for a binomial distribution, Poisson distribution and exponential derivation plus problem we have to study. For last fourth distribution, only problem, no need derivation. So only four distribution if I cover, your unit 2 will be covered. Theoretical distribution will be completed. Such I will give you overall what is the formula for all the four distribution, what is the mean and variance, so that it is easy for a derivation plus problem, it is easy to remember it. So four distribution, binomial distribution, Poisson distribution, exponential distribution and normal distribution. What is the probability, mean and variance? This we know only, whatever it is asked we can do it. So the probability discrete distribution means we will be using P of x for a probability mass function. Discrete means P of x. We will be denoting the symbol to be probability mass function. P of x is nothing but probability mass function. Okay, PMF is nothing but probability mass function. Okay. So P of x is nothing. NCX, this is C is nothing but combination. Okay, NCX it is available in the calculator. P power x, Q power n minus x. X also you have to write. X is nothing but 0, 1, 2, etc. till n. Okay. So it's called for a binomial distribution probability mass function. The mean for binomial distribution NP. Variance is NPQ. So when I have to apply a binomial distribution means when the number and probability P are given, I have to apply a binomial distribution. Okay, only two cases. Probability number of the success and n is the number of the trial. Both are given in the question. We have to apply a binomial distribution. So both it is involved. This is the formula for that probability mass function for a discrete random variable. Same way, Poisson distribution, only the parameter lambda is given. I can use a Poisson distribution. Okay, so probability, same probability mass function is nothing but e to the power minus lambda, lambda power x divided by x factorial, where x is nothing but 0, 1, 2, but till infinity. Okay, so I have to apply a Poisson distribution. The mean for Poisson distribution is lambda, variance also lambda. So both the same, mean and variance are same for a Poisson distribution. You can ask me the question. So what is the connection between a binomial distribution and Poisson distribution? Means both are only, it's approximately will be getting the same. For example, this is when you do the question. Okay, so 0.45 you may get for a binomial distribution, 0.58 or 51 like that. Okay, so for a Poisson distribution only in a decimal it will change. So how we have to, it is mentioned Poisson distribution means go with the Poisson distribution. Sometimes same n and p are given. You have a confusion. Okay. So I can do a Poisson also. So what is the connection between that? It's nothing but lambda equal to np. When n and p are given, convert it into lambda, then I can do for a Poisson distribution. Okay. So when n and p are given, I have a confusion whether I have to do binomial or Poisson, means we can do both. Your option only. You decide it. When n is small, go with binomial distribution. Proceed with binomial distribution. N is very large. Okay, I don't have any limit. What is my small? What is my large, you have to decide it. For example, more than 100 or 1000. So go with your Poisson distribution for n is large. N is small means, for example, 10, 20. So go with your binomial distribution when n and p are given. Okay. So directly lambdas are given, no problem at all. Directly we can go with the Poisson distribution. Okay. So next, third distribution under a discrete random variable. Discrete random variable means we'll be using the symbol for probability f of x. It's nothing but PDF. PDF is nothing but probability. PDF is nothing but probability density function. Probability density function is PDF. Okay. So f of x, how I have to write means f of x is nothing but e to the power minus, okay, so for a, we are writing for an exponential distribution. So lambda into e to the power lambda x. Lambda into e to the power lambda x, where x greater than or equal to 0. 0 to infinity is the limit. Okay. What is my mean? 1 by lambda is my mean. 1 by lambda squared is my variance. Okay. 1 by lambda squared is variance. I have already lambda in a Poisson distribution. I have exponential distribution also same lambda. So you have a confusion whether I have to apply a Poisson or I have to apply exponential. It will be mentioned in the question. It is exponential or Poisson. If they give lambda means they have to mention it is a Poisson or it's exponential. It's not mentioned means go with your option. Okay, so you can do it Poisson or exponential. Okay, so only one thing when you have to check when you do a problem, it is mentioned mean. It is mentioned in the question mean for a Poisson distribution means you have to write what is the mean. Lambda equal to whatever the data, the mean is given to be 5. It is mentioned means lambda equal to 5. But the same it is mentioned mean equal to 5 in the exponential distribution. They have given the name to be exponential distribution. Then we have to check what is the mean for exponential distribution. 1 by lambda. 1 by lambda equal to 5. So lambda equal to 1 by 5. Only difference, this will be the change in the problem wise. Okay. So this you have to remember it when you do a problem. So last is the fourth distribution is normal distribution. We will not use this function at all. Probability or we will not be using at all. But anyway, I have to, all the three you study. The fourth also you have to study. So it is nothing but f of x is nothing. 1 by sigma into root of 2 pi e to the power minus x minus mu the whole squared divided by 2 sigma squared. Okay, where x is nothing but minus x minus infinity is less than x is less than infinity. Okay, mean is nothing but mu and variance is sigma square. Variance is sigma square. So this is the 4 probability distribution we know, means we can do a derivation plus problem we can do it. So this is our note, special note, memoryless property for exponential distribution. So x is exponential distribution, then I can write the probability of x greater than s plus t is given. This not divide, you should not say divide, it's given. X greater than s is nothing but the probability of x is greater than t. It is the meaning, it goes to the numerator minus s and minus x get cancelled, it is greater than t. Memoryless, what do you mean by memoryless property means? So it will lose the memory. So the same normal logic, what is the meaning memoryless means? I don't remember, no, the same meaning, it is memoryless property for exponential distribution. So we have some special cases for a normal distribution, some properties, some 5 properties. It will be useful for a MCQ question, so that I will write it 5. So what is my first property? When mean and mode, median, all the 3 are coincide, okay, at x equal to mu. Okay, it is for a same. So second property, so it is symmetric about x equal to, it is symmetric x equal to mu and bell shape, bell shaped. So my third property, total area, the total area under the curve is 1. As everyone know, total probability is 1. So it is also for a normal distribution also total probability is 1. Fourth is the coefficient of skewness is 0 and coefficient of Curtis's. The skewness and Curtis's will be using in MTech, BTech oriented, it's not there for you, but it's MTech oriented, we'll be studying this. But you have to remember this, it's one of the property. So it is skewness is 0 and Curtis's is 3. Okay. So 5. We have some formula for skewness and Curtis's. Okay, so when you come for a MTech, you can learn that formula and all. So fifth property is add all. When we add all odd moments about mean, when I add it, it vanishes. It will disappear. So this is